All right, this last exercise is not super deep, frankly. It's more of an algebra exercise. Frequently, these are called initial value problems, and the idea is this. You're going to be given a derivative function in each, like in any such problem. Like, okay, here's the derivative. Now, you know that if you have the derivative function, you can find the original function by computing the antiderivative. Take the antiderivative of the derivative, you'll get back the original function. But you also know that when you go from a derivative to the original function, when you compute an antiderivative, you get a plus c, where that c could be anything in general. Well, one of the aspects of these initial value problems is that you are going to be given some value from that original function. Because you see, if you not only know what the derivative is, but you know something about the original function, when you take the antiderivative and you get that c, the bit that you know about the original function is going to allow you to find c exactly, which is then going to allow you to know your original function exactly. And that's the problem at hand. So here's a situation. Imagine we're given this derivative. We know that g prime is 7x squared minus 8x cubed plus 5. We want to find g. Well, first off, you know the form that g takes. Take the antiderivative, x to the 7th minus, that's going to be 2x to the 4th plus 5x plus c. You know that g of x is going to take that form, but here's the thing. We're not just wanting to find g of x in general with the c. No, we're going to find actually what c is, and here's how. Because we know that g, not g prime, but g of minus 1 is 10. So that says when you plug in minus 1, you get out 10. So first, plug in minus 1. Minus 1 to the 7th, minus 2 to the minus 1 to the 4th, plus 5 to the minus 1 plus c. Well, since plugging in 1 gives you out 10, you know that this thing is going to give you out 10. But now check that out. There's a bunch of numbers. There's only one letter. The only letter is c. c can be found. So we've got minus 1 to the 7th, negative 1 times itself 7 times is minus 1. Negative 1 times itself 4 times is a positive 1, so that times minus 2 is just going to be minus 2. 5 times a minus 1 is just a minus 5. Plus c is 10. You can see from this SEE what the letter c is. Minus 3, minus 5, that's all minus 8. Add 8 to both sides. C is 18. Now, knowing what C is, we have found our G. Because we knew our G was of the form x to the 7th minus 2x to the 4th plus 5x plus C. C is 18. Well, that means our G of x is x to the 7th minus 2x to the 4th plus 5x plus 18. We found our original function exactly. You can find the original function with a c by first taking the antiderivative. You can determine exactly what c is using the value that you're provided from your original function. Here's another example. What if you have a velocity function, v of t equals 4t minus 10? And what if you know that your position at time 1 is 4? Find your position. Now, on the surface, this may not look like an initial value problem, but it totally is. Because you know that if you start with your position function and you take the derivative, you end up with your velocity function. Take the derivative yet again, you get the acceleration function. Well, of course, then work in reverse. You know that you could take antiderivatives to get from acceleration to velocity or velocity to position. So if you're given the velocity function and you want to find the position, take the antiderivative. Antiderivative, 2t squared minus 10t plus c. Now, here's the problem. The problem in trying to find s of t is not just taking the antiderivative. It's figuring out what the hell c is. Because once we know what the hell c is, we know exactly what the position function is. How are we going to find c? Well, let's use this other bit of data that we have, in particular, this bit of data that relates to the position function. We know that when we plug in 1, we get out 4. Plug in 1, get out 4. but this is just 2 minus 10 plus c equals 4. That's going to tell you something about what c is, right? Because 2 minus 10 is minus 8. Add 8 to both sides. C is 12. But now that we know c is 12, we know what s of t is. Because the only thing originally preventing us from knowing what s of t was knowing what our constant c was. If you're given a derivative, if you're given a piece of information about the original function, you can find c exactly, then you can communicate the original function exactly, and well, you can get yourself 6 to 8 points on the test too.